Well, it started. A lamp bulb top. But where did we go from here? Right, this is the drawing for the base of the lamp. Here we have the top layer with the cutout for the ball of the lamp. The layer below it has the holes for the wiring to go through. These three are identical as they make up the hollow for where the PCB is, and this one makes up the bottom. And as you can see, there's little holes so that when it's all assembled, these can all be glued together, and then this one screws in. But it also means you can put a screw through here while the glue is drying. And that was all made out of 3mm plywood. So that's how the base was made. And then the next view will be a slightly kind of not very good view through the top of the laser cutter of the bits being cut out. This one was added later because I needed a third hole to take up the space of the board. Originally I just had two, but I had to cut a third one, so I've put it in here now. Alright, here's the sort of bits put together. So I've been going through my junk box. And I think I can reasonably get 5 LEDs in here. Maybe I should turn that round so that the signal goes that way, and then that way. I'll just nibble those corners off. I wonder if it'll still work. So data in, I'm going to have to solder to one end of the pin, and the same with the out. On this side I can go in on the pin, out on the pin, but on this side again I'll have to go in on the chip. But well, we'll see how it goes. After all, this is only just to see if we can do it and what it will look like. I've no idea what it's going to look like. So there's the middle one stuck down. That's coming. There we go. That one's stuck down. That one stuck down. So, how are we going to solder this? Right, we've got some solder. And some nice tin copper wire. If I can find some nice tin copper wire. That's nice looking tin copper wire. What we do is we'll stretch it. and I think I'm going to join the +5 on here to the +5 on there to the +5 on there. So that's going to be quite easy. No real need for insulation on this bit. It's a bit flared out, isn't it? It'll have to do. And then do the same with the ground on this side. Don't really need some insulation for that bit, so we'll just muck it about as we go along. After all, if it doesn't work, we can do it again. But I thought, get the wires down that don't need any insulation first, and then just insulate the ones that do. So what I'm going to do now is I want to run a wire from that ground we do. Actually in focus. I'm just gonna get I don't need so much sleeving on that, so if I just chip that off there. Still need a little bit, got a little bit too much room here, so let's bend that over there a bit. That's it, just to take up some of the room with the insulation. Yeah, it's all very crude, it's just bodging, isn't it? Just bodging the 5 volts and power on. And there's the ground, ground to ground to ground. Volts. Well, at this point I would have been cracking on with soldering all the wires on, but as you can see, they're on. The battery in the camera went flat and I hadn't noticed, so they're all stuck down. That's the plastic globe that's going to go over the top and sits in like that. Now the next problem is that's all the space I've given me, well, given myself, for putting the electronics in. So I dug up a piece of development board and cut it. Well, I would have cut it to fit, but I didn't know a bit big enough, so I just cut it to fit lengthwise. And that will go down there. There'll be a hole. I'll drill a hole for, you know, the cable to go through at some point. And that just leaves me with what am I going to need to do next. Right, so the next thing is, what are we going to need? Got that. A bit of wire out of the way. Oh, everything's moving around. So let's have a quick pop up of KiCad. If I was going to do this, I'd make loads of them. If I had a lot more of these, I've only got the one, I would get PCBWay to make the board for me. But just for one and the prototype, I'm going to prototype it on this board. If I can find a supplier then, and I quite like the project when I finish, I shall make this board on a design, proper design, and I shall get PCBWay to knock up the boards for me, and then I'll have maybe 10 or more of these lamps going. But it's, I'm not going to buy good LED lamps just for that part. If I can go down the dump and find a load of them, you never know. Right, so I'll just pop up KiCad. Here we are, here's KiCad. It seems to be capturing the mouse. So basically that is what WS12B LED tape looks like. It's a whole load of WS2812Bs wired in series, and they have a 100N capacitor across each one, and then the ground supplying the lot and 5 volts supplying the lot. And so that's what you saw me wiring up. So the 3 wires coming out are black and red for the power, and that kind of bluey colour for the data signal. That leaves me with what's left here. Now I've got 100 of these that I bought from AliExpress years ago, so I shall use a AMS 1117-3.3 volt regulator. Now the datasheet says you want a 10 mic on the input and 22 mic on the output. Well, so that my boards don't cost me a lot, I'm going to use a 10 mic on the input and 2 10s in parallel on the output, because you want to use the same number of same components as you can. So when you see over here, 10k, 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 they're all pull-ups, and so 10k, I'll just get through lots of 10ks. Having said that, I'll have to check to see if I've got enough 10ks. And then a little socket so that I can program it, and it's going to have the reset and the program button on it, so that I don't have to reproduce it on here. So just a 6-pin socket. And according to the datasheet, the chip should be reset not by pulling the reset line down, but by pulling the enable line down. Now normally I would have the enable line pulled high because you want it enabled, and I would use the reset to reset it by pulling it down with a capacitor. But the datasheet I looked at said no, keep the reset as is and use the enable to reset it. So that's what I'm going to do. We'll see how it goes. I did have problems with my spiral lamp, and I put a capacitor on the enable line, and that seemed to have cured it. So maybe they are right. So in future, my designs, if this one works okay, will have a time constant on the enable. So don't know. Maybe I should have a short one on the reset and a long one on the enable. Don't know. I shall have to look at what other people have done and find some more data sheets and have another look. Anyway, that's the circuit. Very simple. Load of 10Ks, a few capacitors and a regulator. So let's get back and have a look at the board. So there we are, back to my board, and I have a 6-way connector that I just chomped off of a 40-way one. I might tidy the edges up, I might not. There is 3.3 volt regulator. Here is the ESP8266-12F, I think this module is. And what I've done is, because I'm going to sit it on there, the pins aren't the same spacing. So basically I'm going to have to hold it off slightly. I can't hold it off by much because I haven't got a lot of room. You know, there's not a lot of height in there. And when you've got solder underneath, you're going to have to hold it up as little as possible. So what I have done is, on the safe side, is I've put some capped on tape on the underneath, especially around this area. Now this area has got some connections, but I don't know why they put them there because they're absolutely useless. But that's the idea. That's going to sit, and there's only about 10 wires joining it to the board. Connector's going to go on there. That's going to sit up the top so that the aerial is away from the board as much as I can. Bend the legs slightly so that I can connect it to the pads. And then, due to height restrictions, there might be a lot of hand soldering on the top, but that might raise the board up too much. And if it does raise the board up too much, all I'll need to do is make another one of these. And as you can see from this one, I did have the laser setting wrong, and instead of cutting, it just etched. So to save wood, I turned it over and cut it again. So if needs be, I can get another 3mm of height. I don't know if one more. I'm trying to get away with having it an extra bit higher, so I'll try and get it in there if I can. If I can't, I'll 3D print another one of them and just glue it on. Glue it on top of this one, or glue it onto the bottom so the lid's got an indent. But that's where we are, and so going to stop and have a think about where and how to mount that, and then once I've worked that one out, the rest of it will just fit in. So I'm going to go away and think about that. For you it will just be and I'll be back. Well, while I was away, I drilled a hole for the cables to come out through. I bent the connector pins so they will just sit in there. I got the regulator and I went through my components, and I've got 3 10 mic capacitors, one mic capacitor, 100 nanofarad capacitor, and 5 10Ks. So that's all I'm going to do. And what I thought I was going to do, having also put capped on the back, I cut a small piece of paper that will sit underneath, and that's going to give me the spacing. Now what I was thinking of doing, if I move those out the way because I won't be needing them for the moment, bring this in, protective jaws on, now what I'm going to do is put the board in there just gently to hold it. Better refocus that. Actually I can loosen that. Now the plan is, I can't pick it up, I just cut my fingernails, so I can't pick the wire up. A thin bit of wire, and if I just pop KiCad back on the screen, yeah, it's not very good because I want to look at that bit. Oh well, I'll just put it back where it was so I describe what I'm going to do. Right, there's the actual device, there it is, and it looks like I need 5 wires on one side and 4 on the other. So I'm just going to solder very fine, well not fine wire, but wire on these so that I can just hold it onto the board. So that's what I plan on doing. So let's get rid of that, go back to here. So then basically I'm just going to push it through the hole till it hits my finger, bend it round, and so it sits in the carcellation. And then I'm going to, that's the solder real unsoldering. Let me iron heat up. And I'm just basically going to solder that wire to there, give it a reasonable length, and do the next one. Well, the camera battery ran out again, and while I was waiting to charge up the battery, I had a look at what I had to do and a quick check out to the circuit, and those who might not have noticed, the regulator has changed round. If I just bring in KiCad, here you will see the pin out for the regulator, and I was looking at it, and for some stupid reason I saw ground V in, V out, and so I wired it so that that was touching the 3.3 volt supply, and the chip was at 90 degrees to where it currently is now. So if I come back out of that, you'll notice that the chip has now turned sort of 90 degrees, and supply now comes in from here and comes down in and then out the middle past the 210 mic capacitors onto V in. There's a 100 nanofarad capacitor across there, and then these resistors one goes up there, and then there's a 10k resistor that goes up to one of the other pins as per the circuit diagram on KiCad. And then afterwards, for programming in, I added a line from here that just goes over the top and down to V in, Because also while I was at it, I didn't show any, there's no showing the circuit of it because it's pretty much nothing to it. A little board, it has a 5-pin header, female header here. It has a 6-pin header for the board. It has a reset button and a button connected to GPIO2, which is the prog button. And so basically to program it, all I have to do is plug that together. And this is one of my programmers, which is basically a bog standard. Let's take the tape off. This is a bit of car looming tape that sticks to itself. It's not sticky, it just sticks to itself. So this is, again, USB TTL, and as you can see, it's a bit modified because I've got pins on for the RTS and I got pins on for the CTS, but it still has the standard ground RX TX 3.3 and 5 volts. When I plug it into the unit there, it provides the 5 volts to the regulator, and so I can program the chip. On some of the boards I run the 3.3 volt directly to the micro, but sometimes with LEDs, if you have the LEDs attached, you need a little bit more current, and so it's best to run the 5 volts. But that's basically it. You just plug this in, press the reset, press the prog button, let go of the reset, and program the chip. Currently this has been programmed already. I put WLED on it and that's getting ready to go. Unfortunately the space in here was not big enough height wise for the board to fit in, so as you can see there is a black ring now, and this one is slightly proud all the way around. I had to laser cut another ring, and that's the only one. It was the only bit of board I had left, but it also gives me raw room. I'm gonna sand it down and then glue it to the bottom one. I might even, yeah, I'll glue it to the bottom one. That will give me a thicker amount here, because I've got to drill a hole here at some point before I put the board in, so that we can run power into this. If I do another one, never know, I might put a rechargeable battery. But as I say, this was not meant to be a large project. It's turned into one. So we're getting there. I'll come back, it'll be a click like that, and this will be all sanded nicely, glued, and the board possibly put in. So now I can fit the wiring through the holes, and we'll put the red wire to the positive. We'll put the, of course we'll put the black wire down to the negative, make that a little bit shorter. And that has to go down to there, so I'll make that a bit shorter. Should really adjust the length or the setting on the cutters really, but this is only a quick test. So a quick tin of the wires. That blue wire shrinks back pretty quick, so do the others, which is why I trim them quite short, and then they will expand as they heat up and they shrink in the. But for the moment I'm just going to tack that on there, tack that one down on the negative side. I can actually see what I'm doing. Or just blob that down there. We'll put a blob of solder down there. And that'll do. Not the best soldering in the world, but I've still got to get power into this at some point. So this has already been programmed with WLED. I won't show you how to do that. I think I have shown something, a little board for the programming, just plugs in, attach to it, and see what happens. So let's get some power. I'll just hang the board out a bit, I think, if we can. Lift it up a bit. Oh no, the power I can get. This isn't a very good. My croc clips have hardened, so they don't close very well. I just mangled that with a cutter, so that ain't gonna help, but that'll close. I need new croc clips. Power on there, and it's not going to grip, is it? Take some tape off the front. I had over the front to when I was sanding it a bit, just to protect them. Oh, they'll probably come loose. So put power on. There we have. To the controls. Right, so we've got it up. Go to config. LED preferences. Length. Nope. Go back. 5. Next. 13. Next. Skip that. That's okay. So save. Back. Back. So there we go. Turn that light off. Maybe better. Solid's about the only one. Don't really want to do blink. I forgot to record cutting it. So that's it cut. That's the Raspberry Pi power supply. And turn that back a bit. And then hopefully I am not going to get two of them through that hole. So I'm going to have to use my new Parkside drill bits. I use the old Bosch drill that was fixed many moons ago. It wasn't so much cutting the hole bigger, but breaking it free. And it will go. It will go in. So how am I going to play this now? I've got to get that in there. Sorry, you can't see it. That in there. Curl that up. Make sure I get. It's not the best of holes, is it? Best of places for that hole because of where the antenna is. But, that'll have to do. So that's probably long enough. And now I'm going to have to put some more glue in there and clamp it down. Trusty clamping. I was going to varnish this when it was finished, but it looks like now, because of the way I'm going to have to glue this, it might have to be painted. So can we wick some glue into the joint, and then we'll hold that in the vise until the glue goes off. So there it is, all being clamped, and I shall have to manoeuvre this power lead along that edge best I can. So it wasn't very well thought out. Well, here's a quick look of the finished lamp. I'm gonna wood stain it or something, glue that on, but attached to the power supply, and so one fun little project. Here's a picture of it working in the top corner, and hopefully you liked it. Bit long, but please subscribe, you know, hit like button, hit notification bell to see more, and I'll catch you on the next one.